All right, we're back. Now, we can write this as 0.522, right? Correct? 0.522, right? So that's the molar solution of magnesium hydroxide, correct? Now, I don't really want to, I'm not going to find the pH. Okay, I'm not going to find the pH. That would involve things we haven't talked about yet. Okay? I don't want to find the pH yet. Okay, I will though. So, what else about Arrhenius? Anything else?
The chemical formulas of Arrhenius acids are written with the acidic hydrogen first.
Say this again.
The chemical formulas of the Arrhenius acids are written with the acidic hydrogen first.
So he wrote this. He would write it like that. So the acid is on the hydrogen is on the left. Is that what you're saying? Yes. And for instance, acetic acid. Right? Correct? What about this one? He said hydrogen-bearing compounds are acidic. Finish the concept for me. Hydrogen-bearing compounds that do what? Hydrogen-bearing compounds that do what? Hydrogen-bearing compounds that dissociate a hydrogen ion, right? For instance, this is hydrogen-bearing, but it doesn't dissociate into a hydrogen ion, correct? You get that? Give me a characteristic of a strong acid. It has hydrogen, and what's it bound to? What's it bound to? It's bound to something that is electronegative. So it's hydrogen that's bound to something electronegative. And the more electronegative it is, the better the acid it is, correct? So it has to be bound to something that's going to be electronegative. Now, there are weak acids that, according to Arrhenius, they're weak. They're hydrogen-bearing, but they have two kinds of hydrogens on it. They have hydrogens that don't dissociate and hydrogens that do dissociate. Now, ethanoic acid, which is better known as do you guys read? Do any reading?
Acetic acid.
Acetic acid. Okay? It's ethanoic acid. Okay? Ethanoic acid. It's HCHCOH, right? What gives it ethanoic? It's a kind of a nomenclature for organic chemicals. Ethanol, ethane, two. So you have the prefix. It comes from ethane, ethanoic, noic, oic. Oic means a carboxyl group. That's a carboxyl group. Yes? This kind of the carboxyl group, this part of the is electronegative. It's electronegative, this part of the carboxyl group, so that can come off, correct? You get that? So this becomes an acid because this C double bond O, this part of this compound is electronegative. Is it very electronegative? No. but it is electronegative. So therefore, this hydrogen will come off. And you get this. You get the H comes off, right? And you're left with, each line is going to be a hydrogen. Okay, is that all right? Okay. C, double bond O, O, negative. I like to put it like this, actually. That whole species is negative. That ion. That's the, what kind of ion is that? Remember from solutions? That's the what? Cation? Is this the cation here? What's this called? The anion. It's called the anion. So the anion is what? The anion is negative charge, right? Now, so let me jump ahead a few chapters just to give you a thought puzzle, okay? Let's say I put this in solution. This is this. Remember this polyatomic ion? This is this, right? Is that going to, if I mix that with water, is that going to completely dissociate sodium acetate? Will it completely dissociate in water, yes or no? Sodium acetate. Will it completely ionize in water? Will it completely dissociate based on your understanding of solution chemistry?
Yes.
Yes, it will. It absolutely will. So let's completely dissociate it, right? All right, so I have sodium acetate here. I'm almost done. We have 5-6 minutes left, okay? Don't get itchy. Okay, and that's going to completely dissociate into sodium is going to be a spectator ion. Let's leave sodium out of it. Is that okay? Do you understand that sodium is going to be there? Now, what is the acetate dissolved in? What is the acetate dissolved in? I dissolved a salt into the W word? Water. Yeah. Now, let me ask you this. Doesn't acetate come from a weak acid? Yes or no? Does acetate come from a weak acid? Yes or no? Massa? Yes, absolutely. So what does that weak acid really want to do? It wants that hydrogen attached to it, doesn't it? It doesn't want to let that hydrogen go, does it? In no shape or form does acetate like being alone, does it? It hates it, doesn't it? Matter of fact, it hates it so much, it's going to take hydrogen from water and rip that water molecule apart. Do you get that, Mr. Texas? Do you understand that? It's going to take a water molecule and rip off that hydrogen to form acetic acid again, isn't it? Because it's a weak acid and it doesn't let go of that hydrogen very easily, does it, Dennis? Are you sure? Yes. So, I'm going to write a second reaction. I'm going to say that this is going to mix with water. What are you going to get on the other side when it mixes with the water? By the way, we don't put water in acid-base reactions. We don't use water. So may I erase the water, but we understand the water is there. Is that okay? You sure? Okay. But we know it's in water. So what's the reaction going to be? What are the products going to be on the right side? I just want to know the products. It's going to rip HOH. Isn't it going to rip one of these hydrogens off and become what? What's going to form? What's going to form? Would you say, Mark? OH. Bet your bippy OH is going to form. And then what will that form? That forms OH, and it forms what? What does it form? What does it form? Jen? What does it form? It forms the weak acid, right? Because it wants that hydrogen. Because it doesn't want to be alone. That's what this is about. This is about loneliness. Yes? You get it? You sure? Was that good? A little crazy, but not bad, huh? Okay. So you get this. That's what you get. So let me ask you this. The presence of hydroxide, according to Arrhenius, makes the solution what? Acidic or basic? The presence of hydroxide in a solution, according to Arrhenius, he's the guy that came up with it, makes the solution acidic or basic? It makes it what? It makes it basic. That's correct. Hydroxide means base. What means acid? Ava, what means acid? H plus or OH minus?
OH minus.
What makes it acidic? What did I ask you?
H plus.
H plus makes it acidic.
Yes, it does.
H plus, remember that. H plus is an acid. OH minus is a base. So, when you put sodium acetate in water, what do you get? A base or an acid? What do you get? A base or an acid?
Base.
What do you get? A base or an acid?
Base.
You get a base. So this makes the solution basic. Are you ready? Here's a rule for you. The salt of a weak acid, makes the solution basic when combined with water, correct? Now let me ask you this, and then we're done. You ready? You ready? You ready? Okay. Is carbonic acid a strong acid or a weak acid? It's a very, very weak acid. So if I put sodium, if I have carbonic acid, and then we're done. All right, so give me a minute. Give me a minute. You ready? You ready? This is really cool. So I have carbonic acid. It's diprotic, correct? Yes? So when something is diprotic, the first hydrogen is easier to get off than the second hydrogen, right? The second hydrogen is impossible to get off. But this is a common reaction. H plus HCO3 minus 1. Do you understand that? Yes or no? It breaks down into two ions. So this is called, what's that ion called? It's not carbonate. What's that ion called? In chemistry, when you have a polyatomic ion with hydrogen, what do you call it? You call it bi, Bi. So this is bicarbonate. That's the bicarbonate ion, right? So you ready? We're almost done. You ready? This is exciting. So did you ever hear of this? Did you ever hear that? What's that called? Put it together. It's called sodium bicarbonate. Can't you buy that in the store for an acid stomach? Yes or no?
Yes.
You can. Excuse me?
Isn't that baking powder?
Yeah, but you can buy it in the store, right? And don't people take it for stomach, acid stomach? Don't they? Mix it with water? Yes? Not really good if you're an old person with high blood pressure because a lot of sodium. But, so what does that make it? What does that make it? This happens, right? And what's that going to, remember, that's a weak acid, right? Yes? This is the salt of a weak acid. So what does it make it? It makes it, goes to this. Right? What's that OH do to the acid? Doesn't it? It decreases the acid, because what does that want to do? That wants to take what? What does that want to take? That wants to take a hydrogen that's swimming around in solution and bind it into water. Right? What is this substance called? An antacid. So that's how an antacid works. An antacid is the salt of a weak acid, when combined with water, produces hydroxide ions, and we did the classic neutralization reaction already in chapter 11. Do you remember? Chapter 11. Remember? We said sodium hydroxide, right? Yes? Sodium hydroxide plus hydrochloric acid, which is produced in the stomach. The stomach produces that, right? When I combine these two, I get salt plus water. It's a neutralization reaction. So that's how I just gave you a complete overview of chemistry for the entire book, the entire chapter. I gave you an overview in just talking about antacids using Arrhenius as a model. Do you understand? If you take nothing from today, take this. You ready? Arrhenius is the one who gave us H plus is an acid and OH is a negative. Clear? If you take nothing else, take that. Clear? Do you understand how an antacid works? I'm not asking you to write an essay on it, but do you follow me? But this is why you have to really think about acids and bases, how they actually work. Have a great day.